Hello and welcome to Teaching Mathematics. Today we're joined by Robin. Hello Robin, how are you?
Hi Helen, it's great to be back. How are you?
Oh, good, thanks. I think you come at the beginning of every term.
Seems like I do, yeah.
Yeah, somehow it just works out that way.
Exactly.
And today we're doing grade 10 probability.
Yes, we are.
Yes.
What's the chance that we're going to have a good show?
Oh, it's
100%.
highly likely, yes. Now, if you want to talk to us, remember to use the hashtag MEMaths. Dylan will be watching both feeds. Hello, Dylan, and welcome. Also, you can find us on Facebook at Digital Classroom South Africa. You'll find the post. It's pretty obvious because there's a big picture that says grade 10 probability. Dylan will be watching any comments that come through over there. Talk to us. You could win 110 Rand Vodacom airtime if you talk to us. Awesome. And also, we like to hear from you. And this is a particularly... No, I'm going to change that. People think this is a particularly difficult section.
Oh, but I love probability. It's actually really easy when you get the hang of it.
Actually, on that note, I won 31 Rand in the lottery this weekend.
Really?
I
Was
did.
that, let me guess, one number right?
3.
Oh, 3 numbers right.
3 numbers right.
Wow.
Yes.
That's pretty awesome. 31
Yes.
Rand.
31 Rand. So the drink's on me.
Awesome.
Okay. Now, Robin, you have been here before.
I have indeed.
But why don't you update us? Who are you and why are you important?
I'm Robin, and I used to be a high school maths teacher for 6 years, and now I'm busy teaching teachers at Wits University.
And you're teaching them how to teach maths.
I am indeed, yes.
Yes. Okay. Now, before we begin with all of the stuff, as you know, I've been reading this book. You were actually the one to recommend it.
Teach Like a Champion.
Yes, and there are
Yes.
49 techniques that teachers can use.
Okay.
And at the moment, we're on technique number 21. So Dylan's going to bring it up on screen for us. And it says, this technique involves pushing students to actively engage in the ideas around them by making judgments about the answers their peers provide. Okay, I'm going to explain what they mean, but before I do, I'm not convinced of this. Yeah, I think maybe it's got its place, maybe it doesn't, but it's good to think about everything that's told to you, so I'm going to take it as a good thing. So what he says, Doug Lemov says, is that when a child provides an answer, you should then turn to the class and say, if you agree, stamp your feet. So it's a physical action of stamping your feet to show agreement.
I see it's called Take a Stand. So one idea might be for learners to actually stand up, which I can see might work in a class of grade 8s and grade 9s when they need to get rid of a little bit of excess energy, but I'm not too sure if it would work with my matrics, to be honest.
Yeah, and also teenage girls, actually any teenagers, they don't really want to be shown up as being wrong. So then if they're not sure that the person who's answered the question has done it correctly, maybe they don't want to stand up and be shown as a fool.
Sure. Although I think that that probably speaks to a larger problem in that teenagers are very judgmental, and I've always tried to make my class a very safe space where you're allowed to make mistakes. And if you make a mistake, you shouldn't be ridiculed. You shouldn't be seen as stupid. But it's a space for learning, so it's a space for making mistakes as well. So I think you need to have your classroom culture right in order to be able to use this technique.
I hear what you're saying, and I completely agree. I think that the maths classroom is the perfect place to teach about failure and how to cope with failure and how to get up again.
Sure.
Yeah, however, I think this kind of activity opens the doors up for all sorts of other behavior that are linked to judgmental things and bullying and all sorts of stuff. So I'm not convinced.
Well, I think each teacher can take it as it comes. I mean, there's 49 techniques, and I don't think all 49 techniques will be used in the classroom every single day because that's so many. But some teachers might like this one, some teachers might like another one, and they'll use what works for them.
Yes, and I think this would be very useful in younger grades. Yes, Dylan?
I have a comment on this one.
Yes.
If I may, I actually quite like this idea. I'm not sure why you've read it to be a physical engagement as opposed to a mental engagement. I quite like the practice of getting an answer from learner A, turning around to learner B and saying, well, what do you think of that answer? It doesn't require you to stand or stomp or anything like that, but it does require you to give your opinion about what you've just heard, rather than the teacher stepping in immediately and saying, yes, that was right, or no, that was wrong, or if perhaps that was partly wrong. You can actually get learners to start thinking for themselves whether the answer given by their peer was right or wrong.
Interesting.
Okay.
I like that.
Yeah. The book did describe it as a physical action, but I like the way you've interpreted it more, because it requires more engagement.
Oh, I think it does require more engagement. I think it requires a better level of engagement than simply standing up or
Sitting down,
stomping your feet, and particularly something that can, and I think you were touching on this point, be construed as almost a peer pressure mentality. Well, if those 5 kids stood up, then maybe I should be standing up as well, rather than me being directly asked, what do you think about that particular answer? Did you like it? Did you not like it? Or what didn't you like about it?
And being able to justify whether your friend was right or wrong.
Well, there we go. Send us your thoughts. You remember how to tweet? #EmmyMats. Okay, shall we move on?
Yes, Helen.
Now, you brought a fun Venn diagram for us,
I
being
did.
probability, and Dylan is going to pull it up for us.
Ah, there we go. Well, Helen, I don't know about you, but every now and again, I don't have a clean fork in my house.
No, my forks are always clean.
Wow.
Yes.
And sometimes I can't find the knife. And, well, I don't know, but if we have a look at the Venn diagram over here, what they're trying to tell us is that you don't need to have a fork, a knife, or a spoon. You could just have one instrument that will do the job for all 3.
It would be useful for camping.
It really would, because especially hiking, where you want to save as much space as possible. So over here we see that it's a really nice example of how a Venn diagram works, in that we've got 3 distinct categories: a knife, a fork, and a spoon. And when these cross over, you get this new type of utensil. Like the spork. The spork is a spoon and a fork.
Yes.
And the spife, a spoon and a knife. I've heard about a spork before, but I haven't heard about a spife.
Yes.
And a knork, I don't know about, how would you say that?
Yeah, I would say knork.
I suppose if you say knife, not knife, then you'll say
and no,
knork.
not kno, but yeah.
But let's get back to the maths and not the English. And then we see in the middle, which is the intersection of all 3, we have a splade, which is a knife, a fork, and a spoon all together.
It makes sense to introduce probability or Venn diagrams like this, because then it's not just abstract numbers. There are 3 people who like hot dogs. I hate the tuck shop example. It's
4 people who like fruit juice, and I don't know, 3 people who bought chips, hot dogs, and a juice.
Yes. It doesn't feel like something that they can engage with. Whereas over here, it's like, well, where these 2 meet,
that's what happens.
Yeah.
And I think there are so many. I mean, I trawled through hundreds of these pictures. There are so many great, funny Venn diagrams on the internet. And if you Google funny Venn diagrams, there are hundreds and hundreds of images.
Not all of them appropriate to show to your grade 10s, but definitely get the point across.
Yes. Well, I think that it's the internet is a great resource, and there are very many funny pictures that can be used to introduce Venn diagrams.
Yes. Now, we're also going to be looking at the CAPS document.
Yes, so let's have a look at the CAPS document and see what it is that we're meant to learn in probability. CAPS has changed slightly. When I was teaching about 6 years ago, we'd also do tree diagrams in grade 10. But tree diagrams aren't in here, although it wouldn't be amiss to start teaching them in grade 10 because they are quite complicated. And
it's interesting because they do tree diagrams in Maths Lit in grade 10.
Exactly, yes.
And so it is just an interesting comparison. I'm not saying we should put them all together, Maths and Maths Lit, but yeah.
So in our CAPS document, probability, the first thing is that we compare relative frequency of experimental outcomes with theoretical probability. And that is looking at the difference between if I actually throw a dice 100 times and theoretically what is the probability of getting a 6 or two sixes in a row or or whatever.
Yes, and that doesn't take very long to explain. They
No.
get the idea.
Yeah. Besides, grade 10s get really bored of throwing a dice 100 times, I found.
Yeah.
So it's much easier to work with theoretical probability,
Yes.
in my opinion.
And the next point is Venn diagrams as an aid to solving probability problems.
Yeah, so this is using Venn diagrams and looking at the union and the intersection of different events. And Venn diagrams are a great way of visually representing information that we've been given and therefore helping us solve a problem.
As a teacher, I would probably spend quite a bit of time drawing a Venn diagram, but the CAPS document says Venn diagrams as an aid to solving probability problems. So it almost implies that you should have a pre-drawn Venn diagram and then use it to solve a probability problem. Is that an incorrect interpretation? I'm
not too sure. I think in grade 10, the norm is that Venn diagrams are given to learners and then they use that. Although when it says Venn diagrams as an aid, who's to say that you can't make the Venn diagram yourself and then use that to aid you?
Yes.
To solve a probability problem.
Yes.
Then our next one is mutually exclusive events and complementary events. And we'll talk a lot more about that a little bit later.
Everyone gets that confused.
Yes.
Yes, even as a teacher, you've got to revise it quickly. As they're walking into the class, go, okay, that was that and that was that. And
well, there's nothing wrong with doing a little Google search before your class or checking it up in the textbook. Obviously, you'd rather be right, look it up and be right, than remember incorrectly.
Yes, teach them the wrong thing. It's very difficult to unteach. We all know we're maths teachers. It's very difficult to unteach.
And our last point is the identity for two events A and B. That is, if we're looking at the probability of A or B, it is the probability of A added to the probability of B, and then subtract the probability of A and B, which is the intersection of two events.
It's a lot easier to teach that. Yeah, exactly. And that made no sense to me until I actually saw it represented on a Venn diagram.
Yeah.
And then suddenly it was like,
through it.
Oh,
it's so simple.
So when we get to your Venn diagrams
we'll
later.
Go through that.
Perfect.
Yeah, like I said, it's just so much easier to see things visually instead of be bound to this formula which you learn off by heart but have no understanding of.
Yes. So probability is the last section for grade 10.
It is, and it's taught at the beginning of the 4th term.
So that's right now?
Right now, and after this we'll be going to revision. So teachers, you should be teaching probability, and let's hope that all the rest of the sections are finished already.
Yes. And it is weighted 15 marks of paper 1.
It's weighted 15 marks out of 100 marks of paper 1, which is essentially 15 marks out of 200, which isn't a hang of a lot. It's about between 7 and 8% of the entire year's work.
Oh, well done.
I figured that out all by myself.
All by yourself.
Yes. Well done.
Thanks.
So it is worth spending time on.
Yes.
I'm sure you could use it to revise some concepts.
Really?
You'd
like
have
what?
to think. Okay, let's come back to that.
What's the probability of getting this algebra question correct?
Exactly.
Do the algebra question and look at the relative frequency.
Yes.
Yes.
Or the probability of receiving a particular algebra question in an exam. By looking at the weightings and things like that.
Oh, that's actually really good, Helen. Well
it
done.
could structure your revision later. You could actually use the whole probability section to structure your revision timetable.
Exactly.
Yeah.
Looking at the percentage weightings of each and looking at the probability of getting certain types of questions.
Yes, and then putting them in ratios because, percentages, ratios, fractions, it's all interlinked.
It's all connected.
Oh, fantastic. Yeah. Okay, so 5-point teaching strategy. The first point on the slide says revision of grade 9 concepts of probability and revision of general knowledge of probability, I assume.
Yeah. So, unfortunately, especially in grade 9, because the curriculum is so dense, sometimes teachers don't even get round to probability in grade 9, which is quite unfortunate, but it does happen. So often in grade 10 probability, grade 9 concepts are taught from scratch.
Yes.
However, you should have done probability in grade 9, which means that revision of grade 9 concepts should be done as your first point, or teaching grade 9 concepts. And grade 9 probability it's quite simple. It's just your general probability formula,
Yes.
a number of favorable outcomes divided by your number of total outcomes. What's the probability? And it's good to, at this point, remind learners that a probability scale goes from 0 to 100 if you're working in percentages, or from 0 to 1 if you're working in decimals.
That throws them.
Yes, it really does. And I think it's on one of my later slides about one of the snags, one of the problem areas.
Yeah. Your next point says theoretical versus relative probability, and that's, of course, the first point in the CAPS document as well.
Yes, exactly. Relative probability is what actually happens in real life when you do an event, like throwing a dice or tossing a coin or whatever you choose.
Yeah.
What's another favorite? Picking a card out of a deck of cards.
Yes.
And our theoretical probability is looking at the probability of it happening theoretically.
Yes.
What should happen if we look at the absolute numbers?
Okay, and then you want to move from there to Venn diagrams.
Yes, well, I've actually got a very nice way of introducing Venn diagrams, and we'll get there later, but it's very important that learners understand how Venn diagrams work. Looking at the union, looking at the intersection, looking at the sample space altogether. So I think Venn diagrams are quite tricky to understand to start off with. But the more you're exposed to it and the more practice you have, they get a lot easier to understand.
So in the first point, with the revision of grade 9 concepts, they would have gone over probability is equals to the number of
favorable
outcomes over the number of possible.
Outcomes. Yeah, possible outcomes.
Or total, yes.
Mm-hmm.
Terminology is so important.
It really, really is. Yeah.
So they know that already, and then they go to the theoretical versus relative, and then they move to Venn diagrams. So they do have that backup knowledge of what's happening. Okay, then the fourth point, probability formulae and how to use them, especially in conjunction with Venn diagrams.
Sure.
Yes.
What a mouthful. Well, our probability formulae look at the mutually exclusive events, and we're looking at complementary events, and then we're looking at the other formula that we saw, which is looking at the probability of A or B, which is probability of A plus probability of B minus probability of A and B. And these can help us to fill in the numbers on our Venn diagrams, because Venn diagrams often have numbers, right?
Yes.
And we need to use these numbers to figure out the numbers in the other parts of the circles in our Venn diagrams.
And those would calculate the probability of certain events.
Yes.
Yes.
But while we're here, should we talk about our union and our intersection, or do you want
let's
to
do that?
Actually, I think it's on the next slide, so let's save it for the next slide.
Okay. Well, the fifth point says practice makes perfect.
Yes. And it's like that in maths all over.
Yes.
In every single section. Often we just do one example and then have 2 examples for homework, and when you're done, you're done. But learners still don't really get to grips with what's happening.
Yeah.
So I really think that it's important to practice.
Yeah.
Yeah.
Okay, so the next slide are our 3 pressure points. And the first one says the concept of probability being both a decimal or fraction and a percentage, and how to convert between the two.
Yes,
or 3.
Well, this really goes back to a lot of grade 8 and 9 work in decimals and percentages. And as we know, we've got our probability scale here, and we start at 0 and we end at 1. 0 is absolutely nothing, no probability. If today's Tuesday, tomorrow will be Saturday, 0.
Yes.
1 is an absolute probability. It's certainly going to happen. If today's Tuesday, tomorrow will be Wednesday, yes. But we can also look at this using a percentage scale. So from 0 to 1, we've got decimals. Let's just say we've got a 50% chance of something, 0.5, and that will be 50%. So learners need to be comfortable with converting from percentages to decimals and even fractions.
Yes.
And I think that also just comes with practice, and it comes with a good foundation of knowing where to multiply by 100 and where to divide by 100. I know many learners who just have this little thing that says, if it's a percentage, divide by 100. If it's a decimal, times by 100. And as soon as you change a few things around,
It's gone.
they don't have this. They don't have an understanding. They only have a procedure, so they make a mistake, and suddenly we have 0.5%, which
Yes.
should actually be, 0.005%, which should actually be a
50%.
percentage, but not that.
I think
Yeah.
encouraging them to think about the answer they've got will also
Yeah.
help with a lot of that. Obviously, it's not going to be 0.000. Okay. You
Well, unless
understand.
it's winning the lottery, then it is 0.00.
I got 31 rand, so
but not 31 million rand.
no.
No.
She wouldn't be here today.
No. Or at least I'd have a
Yeah.
new shirt on.
Wow.
Yes.
I mean, I really want to reiterate the point that you made in that learners need to think about it, really think about their answer. If they get an answer which is more than 100%, they need to be able to not just automatically write the number down, copy
Yes.
it off their calculator. They need to be able to think and say, there's never more than 100% chance of something happening. So there must be something wrong with my answer. I need to go back and recalculate and see where I've gone wrong.
Yeah.
Mm.
Okay, the next point, working out correct values for a Venn diagram. Then I really enjoy that because it's like a maths puzzle. You just know
It
that
really
this
is.
over there and that over there, but I understand that not everyone has the same love of maths as I do.
Mm.
How
Well-
do you encourage it?
When I talk about maths, and it's actually in many areas of maths, but this is one of them, I talk about Shrek. Have
Okay.
you watched Shrek?
Yeah, of course.
Many of our teachers have watched Shrek, but I think learners these days are a little bit too
Well,
young
it
for
came out
soon.
15 years ago, so
Exactly.
yes.
Yeah. So Shrek's famous line is, Shrek, I'm like an onion. I have layers.
Yes.
And that's exactly how we need to approach mathematics. So many people try to eat the onion full on, just take a chomp out of it. And as you know, if you eat an onion, chomping an onion, it's really unpleasant.
Yes.
So maths is like Shrek, and Shrek is like an onion, and it has layers, and you need to peel off one layer at a time.
Okay.
I think this is it's a way to say that work systematically.
Yes.
Don't try and do everything at once. All you need to do is take off one layer at a time, and when you've taken off that layer, you see the next layer, and then you'll be able to take off the next layer, and the next layer, and the next layer.
Yes.
So it's all about working slowly and deliberately and systematically.
Yes.
And I think that's a way to approach Venn diagrams. All you need to do, and it's a bit like a Sudoku puzzle as
Yes.
well, is find one value for one section. And you can use that value and all the clues that you have in your question to find the next value. And once you found the next value, then you work on the next value. Don't try
Yeah.
and do it all at once and put in every single thing that you know, because you're bound to make overlapping errors and
Yeah.
that sort of thing.
And if you have a variable, try to stick to just one variable. Don't make this equal to x and that y and
next
z,
Z.
and rather say, well, that one is 3 less than x, so it should be x minus 3.
Exactly.
Yeah. And that's actually quite a mind shift for them as well, thinking
Sure.
of one variable in terms of another.
Exactly.
Yeah.
Yeah. Although in grade 10 we don't quite yet, I think, use variables in Venn diagrams. Although that does come about.
I don't understand why not.
We can.
Yeah.
Yeah. It's a good practice to start using right now. Actually, I'm changing my mind. You're right.
This links back to another conversation I often have with myself, because I'm the only one who finds me interesting. Why are we teaching grade 1s to solve problems with a box as the answer? Why don't we introduce the x there as a variable? I mean, it's pretty much the same thing.
You're quite right. I don't know if I would quite introduce X at a grade 1 level, because I don't think their powers of abstract reasoning are quite there yet, although they are able to see a box.
But
I
yes,
would
the box doesn't necessarily...
Instead of using a box, I would say a star. Because a star looks a little bit like an X, and it's using, instead of an empty space, which is a box, it's using a marker or a placeholder.
Yes.
X is essentially a placeholder.
Yes.
So I think that, yeah.
Another conversation
I would
for
use a
another
star.
time.
Yeah.
Yes. Okay, the last point on 3 pressure points is understanding the terminology, e.g. union and intersection, sample space, mutually exclusive events, complementary events.
So this is where I'd like to draw my picture.
Yes.
And we always start our Venn diagrams with a box.
And the box represents the sample space.
And it represents the sample space.
Oh, good. 5 points to me.
There we go. So everything that happens inside this box.
Yes.
So, for example, if I'm interviewing learners about hot dogs, chips and cool drink,
Favorite example.
all
yes.
of my learners would fall inside, all of the learners that I interview will fall inside the sample space.
Yes.
Even if some of them don't like hot dogs, chips, or juice, which is probably me and you, we would fall inside the sample space, but not necessarily inside our options or events. So let's have a look at this, and we're looking at event A and event B. Can you think of something that's better than hot dogs and chips?
Yeah. We did an example earlier, which was pretty and clever.
Well, there
which
we go.
I think works really well.
Oopsie. I might be pretty and clever, but I can't spell. There we go.
That's okay. Well, then you might
Then I'm not
just
clever.
be pretty. So
if we have a look at pretty and clever.
You might need to write that a little bit bigger.
Thank you. I will do so. I know you're just giving me a second chance on getting my spelling correct.
Yeah, that's it exactly.
There we go. Unfortunately, clever's fallen out of the sample space, but we'll pretend it's still inside.
Yes.
So if we want to have a look at the union. The union is everything that is both pretty and clever.
Okay.
You don't necessarily have to be pretty and clever. It is.
But you're either pretty or you're clever, or you're pretty and you're clever.
Yeah.
Okay.
So we look at this as an or statement. Because
Okay.
you could be pretty or clever. You can be both, but it can be or. And we write this as A and the union of B. And that represents, I'm going to do this in a different color, that represents everything over here. And that is the union.
Okay.
Got it?
Yes.
The second thing that we look at is the... Am I falling off the bottom of the page, or can you...
Almost.
You're good for now.
And when we look at the intersection of events, we are looking at and. So the intersection is looking at both pretty and clever. And I'm going to do this in a different color. And so over here, we have to be both and... I think I've just made it.
Yes.
And that is written like A and the intersection of B.
Okay.
All right? So then we move on to mutually exclusive events and complementary events.
Well, while we're here, that funny formula with the probability of A and B is equals to the probability of A plus the probability of B minus the probability of A and B. It's much easier to explain when you've got a Venn diagram and you go, well, the probability of A or B. Yes. Right. Good job.
There we go.
Is equals to that circle
Yes.
plus that
plus the
circle. But we don't want to add the intersection twice, so we're going to subtract it at the end.
Exactly. Because if we added this circle and this circle, we'd find that there'd be an overlap because we're looking at this space twice. So we have to minus one of them, which is why we minus the probability of A and B.
Yes. And I think teaching this formula without some kind of visual representation like that, it's suicide.
It really is.
Yeah.
Yeah. One of my top tips for learners and teachers as well is draw a picture. Whenever you get something and you don't understand it, draw a picture, try and represent it visually, and when you can see something visually, there's a much better chance of you being able to understand it and therefore solving it.
Yes, and it's okay that it's badly drawn and everything.
Yeah.
But you were moving on to mutually exclusive events.
I was indeed. Let's first talk about the complement.
Okay.
The complement is all of the people who fall into this space over here. So those are the people who aren't pretty or clever.
So that's a complement of pretty and clever.
The complement of pretty is clever and clever are all of the people who aren't pretty and clever.
So not a compliment.
It isn't a compliment at all, but it's the complement. And when we have a look at this picture, we'll be able to see that What was my formula again?
1 minus the probability of...
Yes.
in
Now
this case.
let's just say if we're looking at only pretty, the probability of, and it's usually called A of C, the complement of A is 1 minus the probability of A. So can we see that our events and our complement always add up to 1, because together
Yes.
there's a 100% probability of somebody being something. Right?
Now, the big problem with teaching this formula
Yes.
is that learners don't see the use of it. Or why must they calculate the complement if they can calculate the event? And that's why it's important when teaching this section to introduce a problem where it's complicated to calculate the event, but easy to calculate the complement, and as
Sure,
a result,
sure.
calculate the event.
This can also be used in some questions where there are many Venn diagram questions where it says, I have a class of 30 learners. 5 like Coke, 3 like hot dogs,
Yes.
however many. And once you've added them all up and you've filled your numbers inside your circle and your intersection, and then they say, how many learners don't like anything? That's where you need to use the complement, because it's all my learners
yes.
minus the ones that I've filled in, and that's the complement.
Yes.
So that is also useful in Venn
Yes.
diagrams. Then the last thing that I wanted to talk about, I'm sorry, I know you've moved on, but I just want to talk about mutually exclusive events.
Yes.
And mutually exclusive events is when two things can't happen at the same time.
Okay. That's a fun one to think of examples for.
It really is.
And you don't have to apply it just to maths. You can apply it to everyday
anything.
life.
Sure.
Yeah.
And I mean, you might get something like, I'm a grade 9 learner. I can't be a grade 10 learner too. Those two things are mutually exclusive. I can't be in both grade 9 and grade 10 at the same time. It's just not possible. However, when you get to university,
Yes.
it might be slightly different, because I failed one of my second year subjects, but I passed everything else. So I'm now both in second year and third year at the same time, because I'm repeating one second year subject, but the rest of my subjects are in third year. So
Yes.
can you see how we can use real life examples
Yes.
to get learners to understand? And that brings us to our good ideas.
Yes.
And I've just said the second good idea, which is use real life examples to
And
help
you've
learners.
also said the first one. Get union and intersection
Yes,
right.
that really is important.
Yes. Real life examples, though, you were saying?
Yes, so probability is just one section in the maths curriculum which really, really, really lends itself to real life examples. And we can use the boring ones about chips, Coke, and
Cards
hot
and-
dogs,
yeah.
and picking cards. But they also really are interesting ways of explaining. Just like I said, when you're in school, you can't be in grade 9 and 10 at the same time. Those are
Yes.
mutually exclusive. But in university, there's a probability that you can be in second and third year at the same time.
Now, I was speaking to someone else recently.
Mm-hmm.
I don't think it was you. But they were talking about probability in terms of contraception and getting students to work out the probability of falling pregnant using various forms of contraception.
Wow, that
And-
really can be very applicable.
It
to,
can.
Mostly ladies, but it doesn't happen on your own either. So
No. And to take a probability, a 99% success rate for condoms, for instance, you say, okay, well, 99% success rate. Let's calculate that over 3 years. What is the probability of you falling pregnant over 3 years if you have sex a certain number
X
of
amount of
times?
times.
Yes.
Mm-hmm.
Yeah. And
Wow.
then it's apparently quite a useful exercise. It opens their eyes quite a
Sure.
lot. And somehow teenagers are more scared of
Yeah.
pregnancy than of diseases.
Well, I think another really fascinating way to extend that example is, what if you're on two different kinds of contraceptives, both
Yes.
the pill and using condoms, and is there any possibility at all of you getting pregnant if you are using two different kinds of contraceptive? And that really lends itself to two different events.
Yes. And the right answer is yes, there is still a probability of you
Yes.
falling pregnant. And that must
So-
always come through. It's Yes.
Yeah. Moral of the story.
Yeah. Be careful.
Just be careful, exactly.
Okay, and then the last point involving learners in the lessons. I think that links nicely to your real life examples.
It really does, and it's also just what you've said. I think if you involve learners in the lesson by providing examples which are really relevant to them, then they'll really want to be involved. And I mean, it goes further than throwing a dice or throwing a coin hundreds of times and finding out a relative frequency. It really does help, go onto the internet, find out the probability of something that really means a lot to your class.
Yeah.
And then roll with it.
Well, you could look up probability of getting a bad batch of a certain type of drug in terms of illegal drugs usage. Things like that. Because I'm sure that's pretty high.
I shudder to think.
Okay, so on the next slide, you've got a Venn diagram that shows intersections and how to write the intersections.
Exactly. I put this up just basically so that we could start getting our terminology and also our notation correct. So where we look at the big circles, it's A, B, and C, but where the circles intersect, we've got A and the intersection of B, and the very middle one is the intersection of all three: A, intersection B, intersection C.
You could actually show this kind of Venn diagram next to the splayed Venn diagram that we had at the beginning.
Exactly.
Just to show
how it correlates.
Yeah. Anything else you want to say about that?
No, I really want to talk about this next slide that I've put up, and that is
how it's to name the shaded region.
It's a worksheet looking at naming the shaded regions, and I think while it's very good to really get into the practical side of thing and working with the numbers, it's also good to understand which regions mean what and carry on with that. So, I mean, let's just look at one, for example. We've got A
Which one
and
are you
B.
doing?
I'm looking at the very first one, so number 1. So we've got A and B, and the shaded part is over here and over there. So if I were to name this, what region is it?
It's B.
It is region B. It doesn't matter that it's intersecting with region A. It is definitely region B. However, if we look at, I think I'm going to do number 4 because number 4 is very interesting. So, it's not big enough. There we go. Number 4 looks at A, but not the intersection of A and B. So that would be the probability of A minus the probability of A and
intersection,
intersection B. Does that make sense to you, Helen?
That makes a lot of sense in terms of getting used to how to write probability, and that will help the learners with using the formula as well.
It will, indeed. For example, if I have numbers and I get given the number of people for A, let's say 30, and the number of people for B, let's say 25, and let's say 30 people like Coke, 25 people like hot dogs, and I get told that 10 people like hot dogs and Coke together.
Okay. And then
what is the value over here going to be?
20.
It is, because it's 30 minus these people who sit in the intersection.
Okay, and the one on the other side would be 15.
It would indeed. And how many people do we have all together? 20 plus 10 plus 15 should be 45, or is it 55? Did I make a mistake somewhere?
45.
Have we not made a mistake somewhere?
No, I think you're right, because there are 10 people in the middle. So, yeah.
So our sample space has got 45 people, assuming that there's no one sitting in the complement, as we call it.
Okay. Are you done with that slide?
Yes, I'm done.
Okay, now moving on. This is a very familiar slide or picture to everyone.
It is, and this kind of shows the power of Venn diagrams when it's used in other areas of maths. And when we in grade 8 and grade 9, and we learn about the different types of numbers: natural numbers, integers, rational numbers, and real numbers. it really helps us to order them.
Yes.
And we can see that natural numbers fall inside the category of integers. However, integers are not natural numbers, but all natural numbers are integers. And it kind of gives us a hierarchy. And I draw it slightly differently, where I actually draw rational numbers as a mutually exclusive set
Yes.
to rational numbers, and then put it inside the real numbers. However, in this diagram, there's
a
kind of
mutually exclusive set. And just draw
Let-
what you
let
mean
me draw
quickly.
it.
Yes.
So I will have over here natural numbers. I will have over here integers. I will have over here rational numbers. And then over here, I will have my irrational numbers. And as you can see, they are mutually exclusive.
Yes.
They don't touch. They're very separate. And then I would have a bigger set of my real numbers.
Okay.
Because mutually exclusive means that they'll never be the same thing,
Yes.
right? Rational numbers are rational numbers. Irrational numbers are irrational numbers. They can't be both.
And this is done in the very first week of grade 10.
And grade 8 and grade 9.
So
Every single year.
You
So-
could actually use this as a revision exercise, as well as, that whole concept
really.
of building from the known to the unknown. This could be the known that
Exactly.
you're using to teach Venn diagrams.
Exactly. Yeah.
Yeah.
It's a fantastic way of incorporating revision into probability.
Yes.
Yes.
Because that's what the crunch is at the moment. Okay, so the next slide, you have an exercise for us.
I have a great idea on how to introduce Venn diagrams.
Oh,
to
this
start
is the
off
great
with.
idea.
Well, I don't know if it's that great, but I think it's great. And it's a detective game.
Okay.
And you can make up any situation, but the situation that I made up was that there was a cricket bat,
Yes.
and it got stolen. And there were some clues.
Yes.
And the two clues that we got was there was a size 9 shoe print left in the mud, and there was a strand of brown hair. So using a Venn diagram, we should make a list of suspects by interviewing the class. So here's our Venn diagram, and over here we've got event A, which is a size 9 shoe, and we've got B over here, which is brown hair. So to catch the suspect needs to be in this area over here. It needs to be in the intersection. So, Dylan, do you have size 9 shoes?
No.
Oh. So, well, Dylan isn't even a suspect at all.
Well, he does have brown hair.
I wouldn't say it's brown. I would
a
say
bit
it's
pepper.
salt and pepper.
Salt.
There's about a 50% probability
It
of
was
it.
brown.
But, Helen, do you have size 9 shoes?
No,
But you do have brown hair.
I do have brown hair.
And I don't have size 9 shoes. But I do have brown hair. However, there will be somebody.
Yes.
Let's,
John.
John.
John has size 9 shoes.
And
But he doesn't have
he doesn't
very
have
much
any
hair.
hair, so I think I think we'll put him over there. But there
Yes.
must be somebody. There must be somebody, because we found the clues, who
Yes.
has both size 9 shoes. And I'm just going to say George.
It's always George's fault.
Really.
Yes.
So this is a great way to introduce Venn diagrams by seeing who fits both criteria and putting them in the intersection. And there might only be one person, there might be many, but it's a great game to play
Yes.
where it's interactive, it's fun, learners have a chance to walk around and get rid of some energy while still understanding how a Venn diagram works.
It could turn into a really fun activity, actually, and especially if you get the staff involved and you do, like,
Yes.
which teacher stole the chocolate cake or something, and get the teacher
Or which
involved
teacher
and-
stole my whiteboard marker from my classroom.
But then
Okay,
obscure
that's
questions, like,
Yes.
yeah.
Yeah, and I mean, it could even be that there's a third clue that
Yes.
got found, and the third clue might be
Yeah, it happened on a Friday afternoon. So who has activities on a Friday afternoon?
it happened on a Friday, and of course everyone goes home, so we don't know.
Yes.
There was just one person left. Who was that person? So it's a great way to introduce Venn diagrams and see how they work.
It is fun. Yeah. Okay, now we've got 10 minutes left, and we've got 3 slides.
3 slides? I think there's only 2 slides. Well, we'll see how it goes.
Yes.
I am... 3.
Yes.
Oh, yes, the one is a picture at the end.
Yes.
I remember now. Well, I just wanted to touch a little bit more on mutually exclusive events.
Okay.
And I chose to represent it as a Venn diagram. I know we did the one with rational numbers. But we see that mutually exclusive events, when represented as a Venn diagram, don't intersect at all. And this really brings home that they cannot happen at the same time.
Yes.
And it's a great activity, especially for a grade 10 class, to talk about mutually exclusive events and get them to come up with scenarios that can't happen at the same time.
Yeah. And to test them out as well. Because a lot of suggestions, if you actually test them out, you'll find that they're not mutually exclusive.
Yes.
Yeah.
For example, I can't eat sugar and salt at the same time.
Yes.
But some people eat salted caramel, which is sugar and salty. So there are types of foods that exist being both salty and sugary at the same time. It's a stupid example.
But you get the general idea.
But yeah.
Yes. I was going to say I can't be married to 2 men at the same time, but there are some cultures that allow polygamous relationships. So
our country, case in point.
Yes.
Yeah.
So it's not a good example at all, is it?
Yeah, and you could say, well, where is it mutually exclusive and where isn't it mutually exclusive? In many overseas countries, for example, I would say many European countries,
it is. You can't be married
to more than one person, but in some African cultures and some
even
American cultures.
American culture, yeah. We've all watched Sister Wives. Yes.
Yeah. So there are. It's a great way for learners to get involved, think of their own real life situations, and see if they can come up with with something that is mutually exclusive.
Yes.
And I think my example of you can't be in grade 9 and 10 at the same time is a pretty good example.
Yes. I just think it's boring. I'm sorry.
Oh, fine.
I want to find something that's exciting, but now I'm on the spot. Okay, and then you've got a picture that shows
the complement. So this is what we talked about a little bit earlier. And the complement of A is everything that is not A. So I like this picture because it shows our sample space, it shows the event A, and then it's got an arrow to everything outside of A, and that's the complement. And the great thing with formula is that we know that the probability of everything happening is 1. So, for example, let's say A is you like Coke.
So you would bring back the scale into this.
Yeah, so we look at our scale of 0 to 1, and let's say how many people, the probability of somebody liking Coke is 0.6. So we know that the probability of not liking Coke is equal to 1 minus our probability of liking Coke, which is 1 minus 0.6, which is 0.4. So the probability of somebody not liking Coke is 0.4. And it's a great way to play around with looking at 1 or 100% and working back from that.
And you've got to get them to use the terminology, actually speak it themselves, otherwise they don't internalize it.
Yeah, being able to participate in the proper discourse is very important.
Yeah.
And it works in circles because learners don't always understand what they're talking about, but they need to talk about it in order to understand it. So it's the circular process of talking about something they don't know about, getting to understand it a bit more, talking a little bit more about it, even though they don't really know about it, and carrying on.
Yes.
If that makes sense to you.
We talk a lot about testing out their knowledge, which is really exciting. They propose something and then they test it out to see if it works in all cases. And then they carry on making proposals or making deductions.
Conjectures.
Yes, thank you.
Yeah.
I was looking for that word, couldn't find it. Glad you're here. But I
Sure.
think that's really important and can be used in these kinds of discussions often.
Sure. Yeah, I really want to reiterate the teachers need to model this very precise, correct use of language in order for learners to understand it and then start using it themselves.
Yes.
It's
If
very
you're not
important.
using the language, then
Yes.
don't expect them to understand it or use it.
Yes.
So, do you have any last tips for teachers?
In terms of probability, I think that this is one section where you really can make it fun, make it interactive, use a lot of real life examples, and I think that many learners say, "Gee, I'm never gonna factorize in my life again," but I think there really are real life situations where probability can be used and will be used, not necessarily as a calculation, but definitely as understanding the world. I mean, if we read newspapers, if we look at stats, there definitely is a lot of place for being able to use probability. Yes, Dylan?
Would you say that there's an opportunity, if you don't use the mathematics of probability, to at least use the logic of probability?
I think that's what I was trying to say, and you've said it much more precisely, which is a lesson which we're trying to teach. And I said it in the way, you don't necessarily need to do a calculation, but it will be good for your understanding of the world. So it's good to be able to understand how probability works and why it works. But, I mean, we don't necessarily need to remember the formula for the complement for the rest of our lives. But if we know how it works and why it works, it'll stand us in good stead for understanding.
Yeah. I think my tip to teachers would be to keep a cheat sheet on their desk, because when there are 40 faces in front of you looking at you, you do suddenly draw a blank about how to explain mutually exclusive events, and then to be able to glance down quickly and get it.
Yeah,
it's important.
Keeping a cheat sheet is great, and you can even have your own cheat sheet and give it to the learners as well, and say, this is how I remember what mutually exclusive is, and have a little picture and all the little facts on the side.
Yes.
And so, cheat sheets can be shared with your learners, because it'll become their cheat sheet as well, and it'll be how they remember things.
Yes. Okay, well...
On to our last slide?
On to the last slide. Which...
Helen...
Every man will know what this means.
Well, what I was going to say is, Helen, are you a woman? Do you say it's fine?
It's fine. No, really, it's fine.
Really?
Yes.
Well, I don't know. You see, the reason this works, Helen, is that our intersection of when you say it's fine and it's actually fine is really, really small. So we're looking at the areas of these circles.
Yes.
I know that's not mathematically how Venn diagrams usually work, but because it's a joke, I think it's justifiable in this case. In that our intersection between when you say it's fine and it's actually fine is so tiny. And like Dylan said, I think every man knows what this means.
Yes. Okay, we do need to have something that's more...
That's more?
I don't know, that portrays men in a bad light now, not just women. Because
We'll
I
have
think
to
we're
find
great.
it. I think we are too.
Yes. and
Even though we
the
say it's
intersection
fine,
is-
and our language isn't really precise.
Well, with that, it brings us to the end. Remember that you can win a tablet or a phone by submitting your teaching resource ideas to us. You use the email address competitions@digitalclassroom.co.za. Have a wonderful last term. We've got 2 more maths webinars next week and the week after. So please carry on joining us and interacting with us. Thank you, Robin, for joining us.
Thank you so much, Helen.
And thank you, Dylan, for pushing all the buttons. See you soon. Bye.
Bye.